Hello, my name is Tezu Kim, and I'm a master's student at KAIST. On behalf of my co-authors, I'm happy to present our paper, Winder, Linking Speech and Visual Objects to Support Communication in Asynchronous Collaboration. Student teams commonly collaborate on a shared visual document, for example, a UI design or presentation slides. For successful collaboration, team members should communicate to develop a shared understanding about their document. But students frequently work in remote and asynchronous settings, and this can hamper their communication. As revealed by our interviews with 10 students, this setting made producing and consuming messages more burdensome. For producing, most asynchronous channels relied on text, like instant messaging. But typing involved a high physical demand and made referencing more difficult. For consuming, receivers couldn't check their messages frequently, and thus they had to navigate through a large number of messages, and references could be outdated as the document might have changed. Due to these burdens, students refrained from communicating at all. This led to teams losing their shared understanding and frequently redoing work. Also, even if students did try to communicate, they'll frequently waste time waiting for responses. To address these issues, we designed Winder, a system that supports asynchronous communication in UI design through linked tapes, which are multimodal comments of clicks and voice. Winder is implemented as a plugin for Figma. As the user is working on their design, Winder notifies the user to record a tape every 10 minutes. This prompts the user to preemptively explain the work, such that members in the future can understand what the user did without having to wait for the user's response. To record a tape, the user clicks on record and then starts to simply talk about their work while clicking on relevant design objects.
Today I work on an icon over here and it looks like a fry pan with a neck.
After the recording is complete, Winder generates a transcript of the voice recording with speech to text. Then, it identifies all the moments where an object was clicked and generates bidirectional links between the clicked-on objects and the voice snippets. These links then enable three features which support navigation and understanding of tapes. The first feature is object highlighting on recording playback. When the user plays a tape, the system shows the version of the document when the tape was recorded. And as the tape plays, it highlights the objects as they were clicked on during the recording.
There was too much empty space at the bottom, so I think we should have something else here.
This allows the user to easily find the objects that the voice explanations are referring to and shows what the objects look like at the time of the recording. The second feature is inline thumbnail images on transcripts. For each tape, Winder provides a transcript with thumbnails of the objects clicked on during the recording. By skimming this, the user can easily see which objects were clicked on and what was said about them. And they can skip to interesting moments by clicking on the transcript. The last feature is object-based search of recordings. If the user wants to see all that has been said about an object, they can simply click on that object. The system then displays all the tapes in which that object was referenced, as well as a snippet of the transcript when that object was selected. To understand the effect of Winder, we conducted a 5-day study in which 8 teams of 3 UI design novices worked asynchronously. Through the study, we found that Winder could indeed decrease burden in producing and referencing. Participants mentioned how they spent less effort and were more confident about the clarity of their messages. Possibly due to this, we saw that participants communicated more through Winder. We also found that the 3 features for receivers could facilitate navigation and understanding. The object highlighting helped participants to more easily find the objects being referred to and made them feel like their team members were physically present. The inline thumbnails help participants navigate through messages by providing overviews of each message and navigate within a message by showing which parts talked about which objects. The object-based search boosts the productivity by helping participants quickly find information to start working and allow them to have in-depth discussions anchored on objects. Also, we coded and categorized the tapes to understand how participants used preemptive communication. The main use of the preempted tapes was to describe and justify one's own work, which helped increase shared understanding and decrease confusion. Additionally, tapes were used to coordinate tasks and the territories within the document that each member could work on. Our work presents Winder, a novel tool for supporting asynchronous communication through multimodal input, bidirectional links, and preemptive prompting. In the paper, we discuss how to generalize bidirectional links and suggest future directions to improve on preemptive communication. For more information, please refer to our paper or visit our project website. Thank you.